lessons and you've seen the review, you've seen homework, you've gone through homework 5 and such, and you're working on the summative and you're a little stuck. I will have sent you and shown you these solutions, but just in case you're wondering, I thought I'd go over them here sort of quickly. First, sequences, explicit and recursive formulas. A sequence is a list of numbers that follow a particular pattern. A recursive formula needs to know the prior value, the prior term value. Or an explicit one only needs to know which term number you're looking for. When you're looking at a recursive formula, it has an a sub n minus 1 in it. When you're looking for an explicit formula, it just has the n. Now, given the formula, write the first 6 terms of each sequence. The 3 through 8 here, this doesn't get a whole lot easier. It's straightforward, plug and chug. For these, if you're having trouble with these, please come and see me, okay? But essentially, all you're going to do is, if this is a sub 1, you're going to take -1 and put it in here. So 2 times -1 is -2, minus 5 is -7. Then you're going to take -7 and put it in for a. This is a recursive formula. Number 4 is a recursive formula. Number 5 is an explicit formula. A sub 1, I put in a 1. 3 times 1 is 3, minus 8 is -5. I put in a 2. 3 times 2 is 6, minus 8 is -2. I put in a 3. 3 times 3 is 9, minus 8 is 1. So this one's explicit. Number 6 is explicit. Number 7 is explicit. Number 8 is explicit. Okay? So for 5, 6, 7, and 8, you just put in 1, 2, 3, 4, 5, and 6 for the n. For 3 through 4, you put in the previous term or the previous 2 terms, depending on what the equation calls for. Now, here, TI-84 and Desmos. These are the 2 ways, when you have it in summation notation, to go and use either TI-84 when you're in class, or on the SOL, you could use Desmos. Now, understand that in the classroom, it'll be the TI-84 only. On the SOL, it's going to be, I believe, we've got 1 more year of TI-84 and Desmos. That'd be the 2019-2020 year. And then after that, it's Desmos only. Okay? Now, to move forward, expanding and evaluating a series. What is a series? It's when you add together all the numbers in a sequence. So, first, numbers 10 and 11, it says write each sequence as a series, then find S sub 8. So you're simply writing out all the first 8 terms and then putting it together. So you've got the first term, you've got the second term. And this tells you that you're multiplying. So 2 times 3 is 6. 3 times 6 is 18. 6 times 18 is 108. 18 times 108 is 1,944, and so on. And then you add them all together, and you have this 408,358,721. Number 11 is a little bit easier. Okay, number 10 was a recursive formula. Number 11 is an explicit formula. You put in 1 for the n, evaluate, you get 3. Then you put in 2 for the n, and you get 8, and so on. And then you add them together. Now, while the summative review says to expand and evaluate, I would say just use calculator. Okay, I would never expand these. You should understand what it means to expand it, but if I ever ask you to expand it, I wouldn't ask you to do 16 of them. That gets a little bit repetitive and tedious. So, using the calculator, okay, in this one, I will pull up the calculator and I will do one of these just so that you can see it. Okay. So here we're going to go to math, and then we're going to go all the way down to 0, which is summation. This says k equals 1. Well, we're just going to use x. So x equals 1. We're going to up arrow and say to do the first term through the 16th term. And the way you're going to do this is you're going to do x minus 5, come on the outside, and then tell it that it's squared. You press enter, and voila. Oh, whoops. I know what I did wrong. Math, it's squaring the sum. Sorry, math, 0. We'll do x equals 1 to 16. I just realized where the squared went. Over here, everything has to be inside of here. So I'm going to put a parenthesis and do x minus 5, and then I'm going to square this. Then I'm going to come out here. Okay? So now I get 536. The difference between these two, this first one that I did up here, I accidentally squared the sum. I just did this, I used x minus 5, summed it all up, and then squared it. That's why that's a no-no. Okay? Just have to be careful. Pay attention to what you're doing and think about things that would make sense. Okay? All right. Moving on. Topic 3. Arithmetic versus geometric sequences. In arithmetic, you add. Okay? Geometric, you're going to multiply. You've got a common difference and a common ratio. For each sequence, determine if it's arithmetic, geometric, or neither. Well, that's the first thing. The way you do it, first I would check for arithmetic. Do 12 minus 3, 48 minus 12. Oop, that's different, so it's not arithmetic. Okay, let's write one of these out here. So I would do 12 divided by 3 is 4. 48 divided by 12 is 4. Then you've got 192. Whoops. 192 divided by 48, which is 4, and then 768. Oh, divided by 4. Sorry, it's all 4. I was moving ahead, which means it's geometric. If you were adding it, I would do 12 minus 3, and then 48 minus 12. Those are not the same, so I would have moved on to the geometric. So I'm trying to explain this a little too fast. I will slow down. Okay, over here, this one you have 106 minus 16, and then you've got 1006 minus 106. You don't even have to figure out the exact values. You know this is less than 100. This is way more than 100. Since these are not the same, you know that it's not arithmetic. So then you move on to check if it's geometric. 106 divided by 16. 106 divided by 16 is 6.625. Then I would go to 1006 divided by 106. 106 divided by 106, and that's 9.49 on and on. These are not the same, so therefore it's not geometric. If it's not arithmetic and it's not geometric, then it's neither, and you just don't do anything else. Move on. As soon as you realize this one was arithmetic, -5 minus 2 is -7, -12 minus -5 is -7, and so on, you know it's arithmetic, and your common difference is -7. You do have to go all the way to the end. Okay? So for this, I would check for arithmetic first. If it's not arithmetic, check geometric. If it's not that, then it's neither. All right? Now, writing arithmetic and geometric sequences and formulas. First off, these will be given. These will be given to you, so you don't have to memorize them. So if you've got to write a formula, you look at it. Figure out, what do you know? What do you need to know? Here, I want to find the indicated term. So I want a sub 42. Well, I know a sub 1. I can figure out the difference pretty easily. Okay, -7. Whoops, first I have to figure out if this is arithmetic or geometric. I already figured out that it was arithmetic. D is equal to -7 minus -13, which is equal to 6. And you can go down and figure out the rest of it. So now I know that my common difference is 6, and I've got a sub 1, so I can plug it all in, and I know I want a sub 42, so that's my n. Okay? On all of these, notice on these 4, you know a sub 1 for all of them. Okay? You know a sub 1 for all of them. You also know n for all of them. So now what you've got to figure out is what is r or what is d, and then go from there. Write a formula for the arithmetic sequence and find the indicated value. Okay, first off, this is telling you it's arithmetic. Now, in some cases, you've got to do a little bit of exploring, like in number 29. They give you a sub 1 and a sub 21. You have to use all of that to find D. Once you have D, then you can go back and find a sub 14. Okay, so sometimes there's multiple steps. It's a little bit of problem solving, a little bit of thinking. 30 through 33. Write a formula for each geometric sequence, then find the indicated term. Again, you'll have the formulas. So this already tells you that it's geometric. Make sure on, excuse me, on the test, you read what it says. If it tells you it's geometric or tells you it's arithmetic, go right to those formulas. It's telling you, it's giving you a leg up. If it doesn't tell you, it's a pretty quick check if it's giving you the list. Now here, you've got a sub 1, you know that n is 18, and it's easy enough to find r. All of these pretty much work the same way. All right? Now, write a formula for the geometric sequence and find the indicated value. Here, these 4 take a little bit of work. Sometimes you got to find a sub 1 instead of a sub n. Other times, you have to think a little bit about how to set up the problem because you got to find the r value. Okay? And here, and here. All right? Sometimes there's multi-step. It's okay. You can come in and let me know if you don't get something. Okay? And notice here, I've got a sub 6 and a sub 3. Because this could also be a sub 1, a sub 3. Okay? Remember that we can always just take the distance between 2 terms. Now, arithmetic and geometric series, again, these formulas will be given to you. If it's infinite, check the ratio. If the absolute value of the ratio is not less than 1, it diverges and you can't find a sum. Additionally, if you have n equals 1 to infinity, there is no technology. You have to use the formula. Okay? If there's a number, summation, and this is an n value, then you can use the calculator. So, for each one of these, find the formula, figure out what you know, what you don't know, and go for it. Okay, remember in all of these you know a sub 1. You have to figure out, is it a geometric or an arithmetic? Okay? And then it tells you what the value of n is. And down here, when you hit 43, I would not use the formula. I would just use your calculator. When you take the test, look for all of them that have got the summation notation. As a matter of fact, start at the beginning, just flip through. What are the ones that have summation notation? Go straight to those. As long as it doesn't have an infinity, boom! Just use the calculator. Okay? If it's got an infinity, then you know you're going to have to use the formula. Okay? And here are some more. Again, 44, 45, I don't care if it's arithmetic or geometric. If it's in summation notation, I just plug it in the calculator. Now, as soon as you are asked convergent or divergent, you know that that is geometric, and you're talking about infinite geometric. Okay, so the first thing you need to do is find r, and then ask yourself if the absolute value of r is less than 1. If it is, it converges, and you're going to use the formula. If it's not, no sum. Okay? Those should be pretty quick, pretty easy. And remember, it's not just a fraction. 4/5 converges. Negative 4/3 diverges. The absolute value of negative 4/3 is greater than 1, so it diverges and there's no sum. And here, notice you got the infinity. Okay, I can't use my calculator. No calculator here. Here, I've got to recognize, here's my value of r. Let's use something you can see a little bit better. There's my value of r. There's my value of r. Now I'm going to use the formula that will be given to you. Okay? And if you were to work with geometric series all the time, you'd have the formula down pat in your head. You'd have it memorized. Okay? But in real life, we just don't need to cram all that into your head as long as you know it exists and you know where to find it. Okay, that's your review. The test isn't that hard. Now, do you have some applications? Of course you do. So let's take a look. Here, bricks are stacked in a pile with 42 bricks on the bottom row and 9 bricks on the top row. Each row has 3 fewer bricks than the row below it. Write a formula to represent the number of bricks on each row, then determine the number of bricks on the 7th row. Well, first, think about it. If each row differs by 3 bricks, that tells you immediately, okay, 3 fewer bricks. That means my difference is -3 or +3, depending on which one you want to make a sub 1, okay? Then I'll put or 3. Depends on a sub 1. Okay, so then from there, you just have your a sub 1, your a sub n, so you can plug it in and figure out what to do. Okay, you know you want a sub 7. Now, and again, like I said, d is equal to -3 or 3, depending on who you want to be your negative. Like if a sub 1 is 42, then d is -3. Okay, if a sub 1 is 9, because I've seen students do it both ways, and it would still work. Okay, although let's see here. If you switched it around, it would be a little bit different. But you've got the right idea. Okay. And I would grade it depending on how you did it. But here, 42, 3 fewer would be -3. I don't know why this says 3. Boom. Whoops. Make that a negative. Okay, number 55. A company is offering a job with a salary of $48,000 for the first year, then a raise of 2% each year after that. Write a formula to represent the salary after each year of employment, then determine the salary after 30 years. So, 48,000 is the starting. Why is this 1.02%? Okay. First off, 2% is equal to 0.02. That's your decimal. Then your rate, you're increasing. If I just multiply 48,000 by 0.02, I'm going to have a teeny tiny salary next year. I want to multiply it by the 48,000 and add to that, okay, it's 48,000 plus 0.02 times 48,000. This is 1 times this. Notice that I have a greatest common factor of 48,000, and then it's 1 plus 0.02. That's where you get the 1.02. So I'm growing, and that's where that 1.02 comes from. If you multiply it by just 0.02, it's going to be a tiny little salary. Okay? You're not going to be increasing. Now, number 56, and in this case, number 55 was geometric. 56, the table shows the number of seats in the first 3 rows of the concert hall. This pattern continues for a total of 12 rows. Determine if there are enough seats for a group of 500 people to attend the concert. Now, of course, you could sit here and you could work this out. Okay, how many people? Oops. How many are in row 4, 5, 6, etc. But that would be ridiculous. That would take a long time. And that, by the way, ladies and gentlemen, if you don't know what you're doing and you have to work everything out from scratch, then, and not use your formulas and not use the technology you know, that's where you're not going to have enough time to finish a test. Okay? So it's not that things are timed, and it's not that I'm expecting you to do things with incredible speed, but I am expecting you to know how to approach things. So when you're looking at this, notice that there's a common difference of 2. Okay? So I know a sub 1 is 30. I know I've got 12 rows, and I know the common difference is 2. If I want to know the 12th row has 52. So I can figure out all the way down, a sub 12, I've got 52. Then I'm going to use the summation for arithmetic series, and I find out there are 492. Okay? Determine if there are enough seats for a group of 500 people to attend the concert. And it says that there are 492. That means no, there are not enough. Okay? There are only 492 seats. You needed 500. Okay? That's it. That's your summative review. Good luck on that test.